Welcome to Study Loop.
In this problem, we're given a proton moving at velocity -200 meters per second in the y direction towards a long straight wire with current 350 milliamperes going through it. At the given instant, the proton's distance from the wire is d, and we need to find the total magnetic force acting on the proton. So the magnitude of the force is given by the formula F is equals to QV cross B, where V is the velocity and B is the magnetic field. Now for that, we need to first find the magnetic field generated by the current carrying wire, and the magnitude of that field is given by the formula mu naught times I divided by 2 pi r, where I is simply the current in the wire, mu naught is the permeability of free space, and r is the distance radially of any arbitrary point from the wire. Now we need to write this in vector notation first. Now our current is in the I direction, so the current is going in the positive x direction, so it's in the direction of I hat, which means there will be a circular magnetic field in the k hat direction. So our vector equation will be B times k hat. Now we can substitute our values, so we can just write r equals d over here. That gives us B equals mu naught I divided by 2 pi d times k hat. Now we can substitute in B into our formula for F, so that gives us QB cross B. That gives QV times mu naught I divided by 2 pi d times k hat. Now we know is equal to -200 j hat meters per second. You can actually write that down as 200 times -j hat meters per second and substitute that into our formula, so that gives Q times 200 to -j hat times mu naught, sorry, this was a mu, I don't know why I wrote pi these equations, so that's, make that correction. Mu naught times I divided by 2 pi d times k hat. Now we can collect all of our scalars on one end and all the vectors on one end, so that gives 200 times q times mu naught times I divided by 2 pi times d times -j hat into k hat. Now using the standard basis vectors, we can conclude that this is just equal to -I hat. So that's 200q mu naught times I divided by 2 pi d I hat is our required force. And now we can simply substitute in our values. So F is equal to 200 times the charge on a proton is just 1.60 into 10 to the negative 19 coulombs. That's the elementary charge. The permeability of free space is 4 pi into 10 to the negative 7 Henri per meters, or Tesla meters per ampere. The current we were given is 350 milliamperes, so we're gonna write 350 times the prefix milli, that's 10 to the negative 3, divided by 2 pi times d, and d was given to be 2.89 centimeters, so 2.89 into 10 to the negative 2, which is the prefix centi. And from here, let's just cancel out the pi's, and we can use a calculator to evaluate this expression times negative I hat. And this turns out to be 7.75, so 7.75 into 10 to the negative 23 newtons in the negative I hat direction, or if you prefer the notation where the magnitude's negative, you can write it as 7.75 into 10 to the negative 23 newtons in the I hat direction. And these are our